video together to show you exactly how this is done when you want to remove the secondary winding from the microwave oven transformer core. And this video applies to my homemade battery charger or my microwave oven welder that I made. In order to do this, you're going to need a very sharp chisel. I just ran this over the grinder. Alright, so that's what you want to use, a very sharp chisel, a thin one. You're going to need a utility knife, or in my case just a blade to a utility knife. A plastic putty knife is good, but you can use a metal one. That's going to go between to help protect the primary coil when you're chopping out the secondary. And a hammer. Now you want to make sure you do not want to damage this coil in any way. And luckily there is a piece of hard material right there. You can see it's a flap, and that'll protect the coil if I get too close. When I start chiseling and I get near the bottom, this little plastic should protect me from hitting that coil. Of course, you're going to go very easy when you get to the end, and then I'll slide that in. The back side of the chisel, the flat side, not the bevel. Flat side goes just like that. It's going to take a while, but you will get through it. Just keep chopping. I'm already probably halfway through. There we go. I'm pretty far through, as you can see. I'm pretty far through. I'm probably 70% of the way. Okay. Now I'm going to do a little bit on this side. Hold it flush. Do it again. Okay. See, that's starting to flare out. Now I'm just going to get my blade, cut this in the middle. Right. Keep going. Let's try this one. Remember, you want to go slow when you get to the bottom. Don't go fast. If you damage that coil, you're throwing the whole transformer in the trash. Now, to make it easier to see what you're doing, you could pry off a couple of layers on top. Alright. See, this is the mess you're going to have. Get the utility knife. Get rid of that. Alright. So you can see right now. Alright. That's nice and chopped. Nice and chopped clean, and so is that. We're going to keep going. Let's go there. Now just pry it away. Let's go a little more on this side since it's... We're almost there. This is the spot you gotta be very careful not to damage. Slide that putty knife in. Like that. Alright. Now you don't have to go as close to the coil now as I did. Just cut this away, this loop. Okay, almost got it. Almost. That whole side is off. This just bend inward. Okay, I'm going to do a little more chopping on this side. I'm going to chop a little bit more of that one out. More. It's getting pretty thin. Go at an angle now a little bit. Okay. Bring out. Now we're just going to trim off these excess. Trim off these extra ones sticking out. Pull the paper off. Bend that inward. Cut the red wires out carefully. Position the cutter over the tape so you don't scratch up the magnet wire on the primary. Okay, we're looking good. Trim that short if we want. Bend it straight. Shorter. We're going to get a large bolt and position it in the middle of the copper core, the solid block. As you can see, they really pack it solid when they wind it. So you're going to put a bolt there, a big one, and another one there, and we're going to hammer to drive it through. Okay, I'm going to stand on this. Alright, and once I stand on it, I'm going to take this lag screw right here and I'm just going to hold it right there. And I'm going to tap, and then I'm going to go that side and tap. Alright, you can see it's going in. So now do this side. Sliding, of course, as I'm doing it. Going in, so now this side. Going. This is actually the perfect size, this lag screw. Now if you look at the other side, coming out cleanly, there's a wire that goes from the secondary over to the core. Just cut it. Tap that nice. Go in here. We're almost through. I can feel it's getting really easy to hammer. Be careful the hammer when it goes in doesn't hit that coil. Pull out and up. Okay. See how far we are. Okay, I'm now going to use this rod I got out of a printer. I'm going to put that in the hole. The best thing to use something long like this because you'll be far from the primary and you can't damage it. So now I'm just going to hit it again. And we are out. There you go. Now that's it. We're going to pull out the red wires. That's perfect. The side has the protective paper in there. Alright, so now this is all ready to be wound, so I'll show you how to wind it. Okay, my work area is clean again. There is the core of the transformer. We have a sharp edge here. That's a no-go. So we're going to put a little bit of electrical tape through there. Go in there like that. Reach in with your finger because there's room. Well, mine just barely fits. Just to hide that sharp edge, go over to there. Like that. Tuck that in. Looks good. And that looks good. Okay, now we want to do, you don't have to do this part, but it's good to do it. If you were extremely careful and you know you did not damage the coil in any way, it should be okay. But I'm going to use my digital multimeter. I'm going to put it on a low setting for resistance, which is 200 in my case. So we're going to check the primary coil. It should be very low resistance. Roughly 0.4 to 0.5 ohms, that's fine. Now we want to make sure there's no connection in any way between any of these terminals and the transformer core. We're going to put this on a high setting. I'm going to put it on 20 meg ohms, and if you have a problem between this coil and here, you're going to see it. You should get no reading on this meter right now. Now before we do this, there's varnish on here, so you want to scratch. Alright, so you're going to scratch a spot like this to expose the bare iron laminations, and we're going to check. Well, first let's make sure that's a good spot. Alright, that's a good spot. Yep, shorts right out. Alright, so we're going to leave that probe there. Let that go to zero. Let that zero out again. Alright, now when I touch it to this terminal here or this terminal here, I should get nothing on a 10 meg or a 20 meg setting. That means it's isolated. That's good. Good. So this coil right now tests perfect. The resistance of the primary is fine, and it's not shorted to the core, so we're good on that. Now depending on which unit you're winding this for, if you're winding this for my battery charger, you're going to use 12 gauge stranded wire. If you're going to wind this for the stick welder, you're going to want to use 10 gauge stranded like this. So we're going to put this through here first. Alright, and bend that off to the side. Just forget about it, like that. Leave it just like that. You're also going to need a little bit of soap to put a film on the surface of the wire, the insulation. As the core fills up, it will be more difficult to get the wire to fit through, so you might want to lube it up with a little bit of soap. Okay, pull this wire all the way through. Okay, So right there you can see you got one turn. That's the back side. Alright, push it down to the bottom and let it conform. Flatten out that edge and carefully just push that in. Push that in. So right there is nice. There's nothing wrong with that. You're good to go on that side. So what you want to do now is you want to wind around again, and you want to go on top of this level. So you're going to fill this whole level all the way around. Now to make life a little easier, you might want to just hook the wire into the bottom plate so it stays. Alright, so you want to push it all the way down, and you want to push it on top of that one. Make sure it's nice and flat. Okay, so alright, so what we're going to do now is you want to make sure it's going flat against the wall in there. So just get a screwdriver carefully without damaging the insulation, and as you're pulling, just push the wire towards the core. See, it's flatter now. So that's one turn. Get it flat as you can now because it'll save you a lot of trouble later. One turn complete. Okay. 3 turns. It's imperative that these wires are kept tight. If you make them get loose, they're gonna bag up on the inside, and you will not get all your turns in. Alright, so now we're up to 5 turns. See, it looks good. Now keep in mind, you're only going to fit about 17 to 18 of these turns for the welding circuit to give you the voltage that you need. Good. Okay, this is the finished product. I was able to get around 16, 17 turns. It should come out nice and neat like that. Get this as tight as you can get it in there. Now this is ready to go. This is all ready for a microwave oven stick welder. Alright, so right now what I'm going to do, I'm going to connect my meter up right there, alright, to show you what the voltage output is for winding this. Now because the transformer is pretty powerful, I'm going to be using 2 wires on each terminal. This is going to 120 volts. That's tight. And this one here. And the yellow goes there. Alright, so there. So this will help handle the current better. I have it set for AC voltage, 20. Now when I plug this in, we should get a reading between, say, 13, 5, and 20. Okay, we have AC 16 volts, which is perfect. Let me turn it back off. So we know that the winding is perfect. Let me undo all this. What you have to realize is we just measured AC volts. We will be using DC volts for the welder and the battery charger. Now to convert, once you rectify the alternating current and pass it through a capacitor, the AC voltage becomes 40% higher. So say we had 16 volts times 0.4, 6.4 added to 16 gives us 22.4 volts DC. So two of these combined will give you roughly 45 volts for the welder. Now mine comes out 52, probably because I have an extra turn on one or both of the transformers that are connected in series. For the battery charger, what you're going to do is after you get a bunch of turns on here, you're going to have one end stripped, and then you're going to go to the other end which you did not cut yet in case you want to wind more turns on. So you're going to measure from way at the other end of the wire to this end and take a voltage reading. Once you see you're around 13 to 14 volts, you're done. You can cut the wire right here and you're ready for your battery charger. You want the output to be, once it's rectified, to be around 18 to 20 volts max.